Bismillahirrahmanirrahim. Assalamu alaikum. In the previous video, I have explained the 4 steps of SCADA development. Now in this video, we will implement those 4 steps. First of all, start TIA portal version. I am using version 13 for 1200 PLCs. You need to have installed TIA portal and KP server OPC for your kind information. All these softwares will be used in this video. First of all, click on create new project. Here project name, and you can save it anywhere where you want, and you can also write comment for this project to remember what is in it. So I am writing the name of the project, PLC SCADA class PLC SCADA class 29 to PLC SCADA class 2. Save this. Author name you can use whichever you want to use, and you can also write comment. Now create. Click on create. The project will be created. It will take some time, and then create a project for you, new project, where you can implement SCADA development 4 steps I have explained in the earlier videos. Now click on configure a device, add a new device, controllers, controllers are used for the selecting the right PLCs controllers. You can also connect HMI, and PC system is for SCADA screens. So first of all, I am going to design a programming PLC. So select controllers, the S7 1200, S7 300, 400, 1500, all these can be used for this software. I am using S7 1200, so select your specific CPU, whichever you are using. So I will select my CPU. All kinds of CPUs are available here, and you can choose the correct CPU which you are using for your PLCs, for your SCADA system, to show the data on SCADA screen. CPUs are available in different types: DC DC DC, AC DC relay, DC DC relay, and DC DC DC. So I have selected my CPU 1215C DC DC relay. Click on the arrow, and it will display the type of CPU are you using. It will take some time. This is a heavy software, it takes time, so you need to be calm and cool to go along with me to study completely how the SCADA works, how you can develop SCADA screen, how you can implement the 4 steps of SCADA, e.g. connections, tag assignments, variable field assignment, and assign tags to the variable fields. These are the 4 steps that I have explained in the earlier video. You can go to the previous videos. Now this CPU is open, and now you can select here whichever CPU mod you are using. This is also written on the CPU, and when you click on this CPU mod, it will show its characteristics, what is its memory, input outputs, its operating voltages, its everything is written outside. You can see its description, which is very easy to understand. I'm using my S7-1200 CPU and WinCC SCADA software. So you need to have WinCC SCADA software, TIA portal and KP server installed correctly on your PC, so that you can easily work with it and you can easily design SCADA screen. In this video I will explain the development of SCADA screen and how we can show the data on SCADA screen. Now this is opened and now you can select here signal boards. Signal boards are the IOs, analog and digital input outputs. First one is digital input, second one is digital output. I have taken this analog input. And 1228. So when you have installed signal board, then go to the main, which is the PLC programming window. So main block is the PLC programming window, where you can program a PLC, where you can write a ladder language program for your PLC, where you can create tags for your PLCs. Now I am assigning tags to my PLC input outputs. First of all, go to default tag table and create a new tag table for your PLC program. Click on the tag table and now here you can name the tags. What kind of tags you are using for your PLC program? First of all, you have to create tag table, then you will go to the ladder language to create a program for your PLC. First of all, I write here counter 1, counter underscore 1. Its data type is boolean and it's an output at the position of Q 0.0. You need to change input to output, so it is changed to Q 0.0. This is its address. This is located on the address output 0.0. The next one is input underscore 1 and it is input, so you have to write here input. Output is 0.0. Its address is 0.0, so input 0.0 is my input. Third tag is timer. I am also using a timer in this program, so you can also need to create a tag for your timer too. Creating my tag for my timer to display its values. Timer is timer underscore 1 and we will write its values. Timer is also output, so we need to assign an output value, output address to the timer 2. first step is connections, and the second step is assigning tags. Connection means from where you are taking data. Are you taking your data from PLC or from any other software? I am taking from other software, OPC. So assign here output to the timer. This is not input, this is output. So we will assign here an output address to the timer, which is Q0.1. You can change here its data type, also available in boolean, byte, word, double word. Different kinds of data types are available according to your choice, according to your usage. You can choose the data type. Its value is not I, it's Q0.1. So I have changed its value as timer is output. First step is almost done, and I will now write a ladder language program here for my PLC. First of all, I will take a input and then an output for my counter and other output for my timer. For this I need to draw a line and put an output. Now tags are already I have designed tags, so you can assign tags. Simply click on this box and assign tag input 1. Here you can click on it and assign tag counter 1 underscore 1, and also you need not to write here. These are already you have already written these tags. So assign these videos to the tag your input outputs, and it will work for you. Now you can compile a program to see whether it is correct or not. If there is any error, you need to solve that. And save this program. You can load this program to the download this program to the PLC. Click on download and it will be downloaded to the PLC. If you have connected your PLC, if you have not connected your PLC, you can also implement this in the other way. I will explain to you later. So minimize it, go to TIA portal once again. These were the tags for the PLC. Now create a new project. Now we will assign, now we will create tags for my SCADA input outputs, SCADA development screen, SCADA screen, where I will show my data from the field devices. So this is the project I have created. Now configure a device, click on it. Click on configure a device. This is a heavy software, works very slowly. You need to stay tuned with me to see the whole process, how we can develop SCADA screen and monitor data on it. Now you need to go to PC systems, because you are designing SCADA screen, PC journal, PC station. And when this opens to you, you need to add WinCC RT Advanced. Go to schematic HMI application, drag down WinCC RT Advanced to your PC station. Your PC station is your SCADA screen on which you will display your data. So this WinCC RT Advanced is attached to your PC system, your screen, and it will display your data. Now you need to create tags. You need to create a screen. One other thing, KP server should be on. You need to on KP server before designing your screen, so that you can take data from your KP server. KP server is a software from where you can take your data on your screen, simply to show how we can take data from the field devices. If you have not connected your PLC field devices, you simply can take data from OPC or KP server, which is showing random data in the shape of sine waves, cos waves, and many other waves, which are random, which are displaying random data, and you can display this random data on your SCADA screen in such a way that as it is looking like the data from the field devices. Right now I haven't connected any field device, therefore I am taking data from OPC. So configure program here, go to PC systems. The same process will be repeated, because I have not turned on OPC before. So when you turn on OPC, then you need to turn on your TIA portal to develop your PC station, SCADA system, SCADA screen. So this is now the proper way. First you need to turn on your OPC KP server, then you need to develop your SCADA screen while clicking on that TIA portal. So click here, add new tags table for your SCADA screen. These are my SCADA tags, SCADA_tags. What kind of tags I will display on my SCADA screen? I need to write here. If I am taking these tags from my external devices, then it will be an external tag. If I am taking these tags from the OPC, then it will also be a external tag. Now you need to go to SCADA tags once again, write a tag. I have written a tag counter, one for my counter display, and it is not an internal tag. I will take this data from KP server, so its data type is integer. It will be an integer, and its connection will be made from KP server. So you need to you need to go to here. You need to select the option connections, and my connection is from KP server, so I will write here KP server because I am taking my data from KP server. So you need to write here, if you are taking your data from real field devices PLCs, then you need not to take data from OPC tags. This is OPC, KP server. Communication driver is OPC. OPC stands for object linking and embedding for process control. Object linking and embedding for process control. It is not so here connection, you will make a connection from KP server. First of all, I have make connection, and then I have assigned that connection to my counter 1, so that my counter 1 will take data from KP server. If you have designed, if you have connected PLC, then your data will come from PLC. My data is coming from KP server, so I will display the data from KP server on my SCADA screen to show that how the data can be displayed. The third one is timer. You need to select timer. You need to assign addresses. Address is KP server, and in the KP server from where you are taking data, S7 1200 is my folder in which I have made my options. You need to go simulation examples, and where you can find a randomly playing data, and you can choose any data from that place to show on your SCADA screen. So click on this, and this is the random data, RAM1, RAM2 and RAM3. I have taken here RAM1, and its acquisition cycle, its cycle is 100 millisecond, so that after 100 millisecond it will update its data. You can increase, decrease its cycle time. I am choosing 100 millisecond. You can choose 500 millisecond and any other, whichever you want. Timer, I am assigning the simulation example to the timer 2. Its data is taking from RAM 2. So RAM 1 is being displayed on counter 1. RAM 2 will be displayed on timer 1. Counter 1 will display RAM 1 and timer 1 will display RAM 2. If you are taking data from real devices, PLCs connected counter and timer, that will not be from KP server, that will be from that specific PLC which is connected with your system. Third one is motor, and its tag is also being assigned from random functions of the KP server. So I am taking random 2. You can select any one. Its time is also 100 millisecond. So first step, connection, which I have completed by connecting by assigning my connection to KP server. Second step was assigning tags, and I have assigned tags to my SCADA screen and my PLC program. So its tags are written here in this way. Whenever you write the tags, you need to write tags in such a way that underscore will be mentioned in it. Now I will go to develop SCADA screen. Go to screens on the left side, add a screen, and you can click on screen and go to properties, change its colors, qualities, everything you can change. This is my screen. I can change its color whichever I want. You need to select your own choice and whichever you want to display on your screen. So it has many colors, options with many colors. You can choose whichever you want, whatever you want. Now I am writing the title on the screen, so select the title from a rectangle and expand it to the screen, and then drag a text here and write your text PLC SCADA HMI class. This is my text, and you can expand this text to the whole screen, to the whole title. You can change its size, its shapes, its font size, everything you can change. Now first of all, I will take a button on the screen which is called exit button. This button will be used to exit the runtime. This button, if you haven't created this button, then you can't stop the runtime. So take a button here, write exit on it, and assign properties to it. Click on it, go to events, click add function, stop runtime. This is its function should be whichever you want to assign it, it will do the same function. I need to assign it stop runtime, so this is the stop runtime. So whenever I click on this button, it will stop the runtime. Now you can compile and start runtime. It is compiled correctly, and now you can start runtime to check whether this button is working or not. I have started launched a runtime on the PC. Yes, this is launched. Now the whole screen will be displayed, and you can't skip this screen without exit button. If you have not created this button exit, then you can't stop this screen. It will be displayed forever. If you want to put this screen off, you need to stop your computer. So this button, exit button, is very much important for your screen. This is very much important for your screen development. So exit it, make here the things which you want to display on your screen, create here those things which you want to display on your screen. First of all, select IO field. I want to select IO field for my counter, my timer. So this is for my counter. Tag, also write text on it. This is my counter. Copy its name and paste here. This is counter 1, so that the counter name should be correct according to its tag. Take a second tag, assign its tag, timer underscore 1. Third one is motor. These are the SCADA tags. Tags which you have created. In SCADA tags, you need to assign those tags to IO field. This is motor 1. So the values coming from counter 1, timer 1, motor 1 will be displayed in this IO field. You can increase its digit, you can decrease its digits. Go to properties, click on this IO field, go to properties. From where you are taking its values, go to journal, assign tag, click on tag. This value are being from SCADA tags, so its value should be counter 1. Click yes. Value 1 is assigned. Counter 1 tag is assigned to my IO field, which is designated at counter 1. Just click on second, timer 1, go to tags and select the tag of timer 1 from SCADA tags. Also assign tag to the third one, motor 1. Yes, I have assigned the respective tags to the IO field. Now it will take values from those fields, from those tags. Now my OPC is working. So quick client launch here. I have launched quick client on my OPC to see its values changing randomly. Simulation example functions, go to, and here you can see that simulation example function is displaying some values in data type long, float, strong, string, and many others. I have assigned 3 values. All those values will be displayed when quick launch is turned on. This is OPC. This quick launch is, I have launched from OPC KP server, which I am using here in this software. So after launching quick client, you need to go to your program, see your tags, all those are assigned correctly. Yes, it is. Now save your project, compile it. Yes, it is compiled correctly without any error. If you have an error, you need to remove that error timely so that it can start runtime. So click, now I am launching runtime. Yes, you can see that counter 1 is displaying the ramp 1, timer 2 is displaying the same, the other one, and the motor is also displaying. So these values I have taken from the KP server OPC. You need to take these values from field devices, PLC related counters, timers, motors, which are connected with your respective PLCs. This is a simple way in which you can test your field devices. You can take your data from your field devices. You can analyze your data from your field devices, whether your SCADA is displaying your data on the screen or not. You can change also, if you have connected your real devices, you can change this data. If you have, if you write here and click enter, your data will be changed exactly on your field devices too. So this is a random data which is coming from a software, not from the real field devices. So this can't be changed. But if you have connected your real field devices, you can change your counter value. You can change your timer value. You can even change your motor value. You can change the RPM of your motor from here. So excited. Now I want to display my data on this tank. I need to write a VBscript for this tank and assign tag to it, and I have to write extra tag for my tank here in SCADA tags. So you need to write a tag here in the shape of tank, whatever name you want to assign it, it will be displayed. This is tank underscore integer. Its data is not coming from the KP server. Its data will be assigned from the internal tag. Internal tag is the one which is in the software, which is not from an external software like OPC or KP server. This data is coming internally from the software, from VBscript. So I will write a script for a formula for the tank, that how it will display my data. And I want to display the data of counter 1 on my this cylinder, this tank. So I have assigned internal tag to tank. You can see that you need to change time to if you want. So go to scripts, VBscripts, add a new script, VB function 1. So you need to write, rename it, it's my script underscore script. So write here formula on the basis of which your cylinder, your tank will display the data of counter 1 or whichever you want to assign to it. You need to write a formula which will display your values on your tank in such a way that it will be displayed correctly up to its limits. It have a limited range. This range should be kept in your mind. So VBscript is the script where you can write a formula for your analog display. I have shown you digital display previously. Now you can see that how we can display our data on an analog scale. So this is my tank and I want to display the data from my counter 1 on this tank. So you need to first of all you need to go to your tank and write here its name. Its name is simply tank underscore integer int. So I will write here script for my tank. Its range is from 0 to 100. So its tag is correctly written here in SCADA tags. You can see that it is an internal tag, not it is coming from KP server. So its data is coming internally from the software. It will execute software data of your script. So I will assign my script to it so that it should take data from my VBscript. You need to stay tuned with me to the end of this video. I will display my data on the analog cylinder, and you can see that we can display data whichever type, whatever type you want to display in it. I can display it analog, on the analog scale, on the digital scale, on every scale, whichever you want to have on your software. So go to script, write script here. This is my script, and I will write first of all you need to copy the tag from this tank right here, paste here tank underscore integer. This is equal to counter 1. So I will write here, this is counter 1. I want to display the data of counter 1, so copy it and paste here, and it is divided by 1. It means the exact data of counter will be displayed on my tank. Data if divided by 1, it means that the same data will be displayed of the counter on my tank when I turn the screen on, when I start the runtime. So this is written here. This is a formula. You can change formula according to your needs, according to your requirements. I want to display the data of counter 1 on my screen, so I have written it in this way. You can change in your own way, whichever you want. Formula can be changed, everything can be changed. This visual script is used to write your formula. You write your script for your analog data display. So I will now go to my SCADA tags. Tags are correctly assigned. Go to counter properties, events, add function, change value, add function, and then VBscript. This is the function which I have assigned to my counter, my script. So it will take values from my script. Now go to screen, assign tag to your tank. I have deleted its name, So click on it and go to properties, journal. Here you need to select process tag. Process tag is data is coming from tank integer. This is the SCADA tag. So you have selected it correctly. This formula is also correct, and you need to now go to compilation. First of all, check everything. If it is working, it is correct according to its tags. Then you need to see everything in detail. Go to save your project, compile your project. If it is compiled correctly without any error, you need to start runtime. Yes, I have started runtime. Now you can see that the data of counter 1 is also being displayed on my tank, and it is going from 0 to 100. Yes, it is not going above 100. You can see that my tank is showing analog data. Is showing data on analog scale. In this way you can display your data. In this way you can show your data on your screen. So this is the SCADA development in basics, how you can develop SCADA screen, how you can display your data on your SCADA screen, how you can monitor data on your SCADA screen. This is a very simple way to discuss it in detail, and in the next video I will discuss in detail its other functions. So stay tuned with me, and the next video will also be very much informative for you. Thank you so much for watching this video.